Good morning, everyone. Thank you for being here. I like the Monday morning sessions, right? We are fresh and early in the week, not influenced by other things, still excited and eager, so this is good. So I'm glad you're here. My name is Chaitra. I am a Gen AI specialist at AWS, and today I'm joined by my colleague, Amna.
Hello, everybody. I'm Amna. I'm a senior specialist solutions architect for generative AI.
And we have Dave from Sage, who is one of our AWS customers.
Hi, I'm Dave Senior. I'm based out of Dublin, Ireland, and I'm the head of data and AI for a central services team in Sage. We're part of the product org. Everything we build is customer facing.
Thank you. So, why are we here today? What are we going to learn about? This is what started to happen, right? Chatbots. And it seems very simple. You put a prompt, you get a response. That's how it started a few years ago. But we know, in reality, it's much more complex than that. There's orchestration and agents and RAG and applying safeguards. So it's not as simple as this kind of LLM that generates everything. Imagine this, right? You're talking about one application before. Now, we are at a stage where we are going to put a lot of this in production. So what are some of the challenges and complexities here? It's not a trivial job. It's really complex. So that's what we will try and address in this talk today. We will see what that strong foundation looks like for you to take these generative AI and agentic applications to production and even at scale. It is a comprehensive foundation that we have defined, but we'll just dive into a couple of layers, look what are the details there, and then we'll have a demo of a foundation that Amna has developed just to demonstrate how it, in real life, it looks like, what happens when you start to put all of these foundations together. Then we'll hear from Dave of their journey of building this agentic mesh platform. We'll look at operating agents, and then we'll wrap up. We'll show you a few resources to take back. Can I get a show of hands of people who have developed proof of concepts, either generative AI or agents? Nice. What about taking it to production? That's more than I thought. And I hope that's all on AWS. Okay. So we know that it's not trivial. We already understood scale is a challenge. But even taking a few applications to production is a challenge. And all of the challenges we have talked about before, taking things to cloud, taking things to production, are still valid here. But it is a little bit more than that. In terms of performance, agents are not just reactive. They reason, they plan, they act over extended sessions. So low latency and performance is important, and that is a really hard optimization challenge. Scalability, when you put thousands of agents in production, you want to look at some purpose-built orchestration, some purpose-built infrastructure to handle that scale. And these agents are accessing sensitive data. They may access tools that have access to sensitive data. So without proper isolation controls and identity controls in place, even a small error can cause catastrophic problems. And these agents need context, right? And evolving context. And they have to be updated regularly and at scale, and they have to be secure. This memory has to be secure. That is another technical challenge, to give a memory that scales and is secure. Till we built generative AI applications, applying safeguards was good, right? Guardrails. But now with agents, you have to continuously monitor, continuously evaluate, continuously audit, and maybe even have human oversight in place so that these agents are aligned. Okay, we all understand it's very complex. So what are we saying? We are saying that have strong foundations in place. And what does that mean? You can look at it two ways. It's either you're building one or many applications, and you want to set up the foundational architecture in place. Or you can look at it another way, that you are a platform team, an IT team. You are setting up this central platform, and you're onboarding different lines of business or teams. And what does that look like? So I'm not going to go into detail here. I have another slide which talks more in detail. But the idea is that you start to consolidate components and offer as shared services, and you have this kind of governance centrally control in place. So it may be any policy, compliance, security, even you start to see cost efficiencies, right? So one example of a shared service could be that a model catalog. Everybody who builds the application don't have to have a model catalog to access. You can put that in a central place as a platform offering, and the teams that are building these applications can access that. But what does that look like? So we are saying it's a comprehensive foundation. At the core of it is the hub, which is the model hub and the agents and tools hub, and giving access to these via gateways. And then you're building these agents, you're customizing these models, you're building these tools. You need an execution environment, a runtime to host these. Data. Data is in silos, data is in data lake, data warehouse, but you don't need all of that data to build these applications. So this layer concerns about building ingestion pipelines, building indexing pipelines, taking that data and putting into vector stores, and having long-term and short-term memory stored for agents. Then on top is the orchestration. Orchestration is more about, okay, I have access to all of these. How do I really build this flow? It could be a workflow, which means a known series of steps, right? Query calls a model, there's another prompt, maybe you're chaining different models, you're building a RAG architecture, or it could be agents. But that doesn't necessarily mean it's part of the foundations, but orchestration can become an important layer if you want to give templates, right? There is a common data, you want to give a RAG template for that so that everybody can use. It's a good place to put that in the orchestration layer. Then you have clients accessing all of these. And let's not forget the three most important pillars: operational excellence, observability, and security. Observability is very, very, very important to get some insights into what is going on. These are black boxes. So how do you really know what is happening under the hood? And we'll talk a bit more on that. Operations, it's not just about operating the foundation. It's about what do you offer to these applications as part of this foundation that helps them operationalize. It could be something like a prompt management store to store and version the prompt templates. It could be part of the foundation that these consuming applications and teams can use, right? And let's not forget security, data privacy, data isolation, all of that comes into play. Now, I know it looks like this big thing, but we'll dive into a couple of them. Before I dive into the layers, there are two services I want to talk about, which is Amazon Bedrock, which is our fully managed service that lets you build generative AI applications. And you get access to state-of-the-art models, first-party and third-party. You're able to scale cost-effectively because you have different consumption modes. You have a lot of features here that lets you balance out latency, cost, and accuracy. And you can customize the models with the data or build RAG architectures. And then you can apply guardrails using the guardrails feature. The other service I want to talk about, which will help you build that foundation, is Amazon Bedrock Agent Core. You may or may not have heard, may be familiar. This went GA a few weeks ago. And this is our fully managed agentic platform that gives you a lot of managed services to build and scale agents. It gives a secure runtime to build and deploy these agents. It gives memory, long-term and short-term managed memory. It has a gateway to access tools, and all observability and instrumentation of traces all built into the platform. So when you put the two of them together, this is what it looks like, right? You have Amazon Bedrock. We talked about the model catalog and the gateway. Bedrock will help satisfy that model catalog requirement. And then we are talking about runtime to deploy agents and tools, and Amazon Bedrock Agent Core will help you do that. Now, the big advantage of Amazon Bedrock Agent Core is that you can use many different open source frameworks Strands, Crew AI, LangChain, Llama Index to build these agents, and you'll still be able to deploy all of them in the runtime, right? You containerize them and deploy them, that's it. The service manages it for you. So this is good, right? We looked at what a comprehensive foundation looks like. Let's dive into one of them, gateway. Now, we are seeing a few patterns emerge. One is called the LLM gateway, and this has been there for a bit, I would say. This is all about giving secure access to a model catalog, right? And it gives a unified API so that developers don't have to worry about accessing different models with different API specs, different prompt templates. So this can handle all of that. Now, the two other patterns that are emerging are that one is tool gateway and one is the agent gateway, right? These are becoming popular. Tool gateway is about, it secures and standardizes actions and integration. And registry is a central registry of tools that agents can access. Similarly, agent gateway gives access to agents, and agent registry is a catalog of agents which are deployed. All of their capabilities, metadata, even registering and deregistering agents all happen. Now the question might be, do you need all of them? Not necessarily. It depends on what kind of use case are you building. So for example, if you look at the LLM gateway, why do you need an LLM gateway, right? If the models are on Amazon Bedrock, which is our service, if you may have customized models and put it on SageMaker, that is also one of our managed service, or it may be on EKS that you have hosted, or it may not even be on AWS, it may be from another provider. Now you want to reduce that friction for developers in accessing all these different models, right? You don't want them to worry about it. So the gateway takes care of that orchestration. It gives a unified API. Mostly it is an OpenAI specification that we have seen with all of these tools. And most of the cost that we see is a token cost that you want to control, you want to attribute, and this can do cost attribution. So as use cases come in, you can see which use case is using the most number of tokens, causing the most dent in the budget. And you're able to apply rate limits to all of these different teams. And the way it's done is you hand over API key to all of these different teams or users, and then you can start to track costs and all of the actions. Now, the other big advantage is you can apply guardrails. Let's say enterprise-wide you have some guardrails that you want to apply always. Whoever builds application accessing these models need to use those guardrails. This is a great place to put them. Now, all the foundation that we showed doesn't mean that we have a service for every one of those layers. No, we do have gaps. And one of them here, what we have done is we have published a solution that shows how can you deploy in a well-architected manner a solution, an offering that is available outside on AWS, securely, cost-effectively, and reliably. Now, this takes an open source solution called Light LLM. You may have heard. Can I get a show of hands if anybody has used? Yes. So they have two versions, an SDK and a proxy server. So this takes the proxy server and puts it in EKS or ECS and deploys it. Now, Light LLM comes with all of the features that we talked about for an LLM gateway, right? So this is just about taking it and containerizing it and deploying it on AWS. There are a lot of other solutions as well. For example, Kong AI Gateway has this, Envoy, Open Router. So there are a lot of solutions that you could explore. Now the question is, if you are just accessing models on one provider, one service, you may not need this, but still, if you're looking to do cost attribution and segregating and isolation between different teams, it's a great thing to have a gateway in front of the model access. Now, the next thing we want to look at is the tool and agent registry. Now, the pattern that's coming is, yes, there are purpose-built gateways and registries for each of these, but they can also be combined. There are solutions that are coming that are combining these two things and giving us a service. One of the example of tool gateway is Agent Core Gateway that comes as part of Agent Core. It provides unified access to all of the tools. It could be that agents are running in agent core or outside, it doesn't matter. You could still use the gateway. And you are able to access either API endpoints, Lambda functions, MCP servers. You attach them as targets. This creates an MCP endpoint for all of those. And the agents are able to discover these using semantic search capability of the gateway. So this is an example of tool gateway that gives kind of a registry and a gateway to access the tools. Now, the other solution I want to show you is this open source solution that some of our colleagues developed. This is like a comprehensive gateway and registry. MCPs, agents, and to access both of these. It's open source, it's available, so feel free to check it out. And one of the good things is it's enterprise ready, observability is integrated into it. So the way it works is there is an Nginx server endpoint in the front, and rest everything is deployed as MCP servers in an EKS cluster. Now, it also supports two types of authentication, M2M using JOT, and then the 3LO authentication. So it's really good, works as both, and a lot of development is happening. Even you are free to contribute. It's open source, so take a look. Okay, so we looked at gateway. There are a lot of different layers. We are not going to go into everything, but I do want to talk about one very important topic, that's observability. Now, we know I have built software applications. I have been in this industry for a long time, so I've built them. So at that point, observability for those apps was more about keeping the systems alive, right? We were worried about uptime, latency, and errors. But now what has happened is it's about keeping the systems aligned. You are worried about quality, bias, right? Is there any toxicity, hallucinations that are going on? So whereas earlier it was infrastructure monitoring, now you're almost monitoring intelligence. So why do we need it? Quality is very, very important. You want to understand the quality of the response. You want to understand the right tools are being selected, right? Agent works by having access to many tools. So is there right tools at its disposal? Is it picking the right tool? Is it converging the right path? Convergence means, is it taking the shortest path to get to the response? So all of that is quality, right? Cost implied, you want to definitely understand cost. Latency, not the system latency, but why is an agent taking time to respond? Which step in the process is taking time? And then you also want to measure risk. Risk is the most important thing. And how do you measure it? Seeing if there is any PII leakage, is there any toxic output? There are ways to do it, and I'll talk about how you would do that, right? So this is how an observability system works, right? Your agents are generating operational and semantic signals in the form of logs, traces, metrics, and another important metric is user feedback. It has to be collected. Now, what the observability platform/tool will do is it will aggregate and visualize these signals. And another important thing, which a lot of times it's not set up, is the evaluation layer, right? Its job is to interpret the quality and risk using some evaluations. You can collect all the matrices you want, but if you do not use it, if you do not use for evaluation, then there is no benefit other than understanding cost. So once the evaluation layer, you evaluate all of this, then it's the optimization loop that happens where you know, okay, it didn't really generate the output I want, so now I'll use a different model, I'll use different prompts, or you make some changes, and this loop continues. This observability platform could be any tool. LangFuse, for example, is a great tool. Agent Core has observability. That is a great tool. So you can plug any one of those tools here. Now, what are you measuring? Functional, we understand. Quality is what is important. As I was talking about, even in, let's say, a retrieval augmented generation app, is the retrieval relevant of what is happening, right? Because the chunks are extracted from the vector databases based on the prompt. Is it identifying the right chunks? And is it finding the right tools? Is it passing the right parameters to the tool? That's the second quadrant. And the fourth quadrant, user feedback, is also important. Yes or no, and then this response works or this response works, giving them two choices. And you could also imply certain attributes like, for example, if the user is prompting the same thing again and again, maybe the answer is not satisfactory. Safety, toxicity, and PII leaks and bias, very critical to measure all of these. This is not a comprehensive list. There are many more that you can start to measure, but these are very, very key and important metrics. There are two types of evaluation. Offline is done during development. Integrate this into your DevOps pipeline. Continuously evaluate the system and applications. And here, the data set that you use is kind of a golden data set that you have created. And it could be user annotated or synthetic data set. And once that is done, then comes the online evaluation, wherein real user interactions are being measured. This is in the live system. Now, you don't have to measure every trace that's coming out of the observability system, but if it's a very high-risk application that you have, it makes sense to measure every output and see if it's performing the way you're expecting. Otherwise, you can sample certain data set 5%, 10%, and start to evaluate those. And then continuous iteration is important. Now, just the life cycle, you start, you define your goals and metrics, and then you curate this golden data set. Do not forget that. That golden data set is so important. You may think, I will just develop the application, put it in production, and see how it works. No. You develop the application, you test with a golden data set, and then you put it in production. And then test, test, test. Test under different conditions. And the way to test there are three different ways to test. One is you use automated evaluation, which means you're using some kind of coding to evaluate, or you do some kind of regex, or you're comparing it to a ground truth data set. The second way is to use another LLM, another model, to look at the output and say, hey, here is a prompt, here is the output, and give me some measurement. And the prompt for that LLM should be very good. Use a really good LLM, and this is called LLM as a judge. The third is you can use humans. The most expensive, but you can create queues, you can have humans evaluate, maybe more close to accuracy, but also think about the cost. And then the continuous optimization. Now, how would you do this? Observability can be integrated and implemented two ways. One is all of these observability tools come with an SDK. You can use that SDK, build that instrumentation into the application. Like, for example, LangFuse. LangFuse will have an SDK that you can use. The other way to do it is you collect all the traces, feedback, into an OTel collector. It's a standard for collecting and processing telemetry data. And then you can feed that off into different systems of how you want to measure. Means it can go into CloudWatch, which is a service of AWS, and there you can create dashboards. Or it can go to Amazon S3, which is our scalable data store, and from there you can do some offline analysis. Or it can feed into these systems like LangFuse, from where you can do a lot of insights, you can analyze that, and feed it into evaluation layer. Now, let's look at a demo from Amna. And sorry, I'm looking at my clock. That clock is not working, so come on.
Thank you. Thank you, Chaitra. Really excited to share the stage with Chaitra and Dave today. Chaitra walked us through the journey of building foundational components to scale generative AI applications into production. But how many of you are wondering how this looks live in action and how you envision this tangibly? So I'm really excited to share that my team has open sourced an accelerator called the Agentic AI Foundation Accelerator, which basically ties or stitches together a lot of the foundational components that Chaitra was talking about, including a generative AI gateway, observability, offline evaluation, guardrails to safeguard your application, and also infrastructure as code deployment. So this is a lightweight but well-architected foundation that gives you, the opportunity to deploy this solution, leveraging infrastructure as code using Terraform, and helps you host your agent in a secure and scalable fashion, leveraging Amazon Bedrock Agent Core runtime. So what you see here, right, on the center top is Amazon Bedrock Agent Core runtime that helps you host the agent. So in this demo, we are leveraging an open source framework called LangGraph, but you could possibly bring your own framework. It could be Strands, Crew AI, your own code logic, your own implementation, and host it on runtime. And then you see on the bottom, in the center, the LLM gateway, right? So in our accelerator, we are leveraging light LLM guidance that Chaitra mentioned earlier to enable the agent to invoke any model of your choice that's not just on AWS landscape, so not just on Bedrock, but also beyond. So our accelerator also helps you leverage models that are on SageMaker or by third-party providers. So that's also another aspect. The other thing is that the LangGraph agent that we have, in our case, is using 3 different tools. So the use case that I will demonstrate today is a very simple customer service chat application, but you can also basically adapt this foundation to your use case, to your industry. The foundations remain the same. You basically, again, the code and the implementation based on your processes. So in our example, the agent is leveraging 3 tools behind the agent core gateway, right? So Chaitra also mentioned the tools gateway. So behind this tools gateway, what we have is 3 tools. The first one is a RAG-based tool, which is helping you retrieve context from your enterprise indexed data. This is leveraging Amazon Bedrock knowledge base. The other tool that we're leveraging is third-party APIs for creating and providing information for support tickets. So for example, your agent is not able to answer a customer query. So then the agent routes this and creates a support ticket. The third tool is a web search tool, which is also behind the gateway. It's leveraging third-party API with Tavily. Now, all of this is then being audited with the help of not just Amazon CloudWatch that you see on the right end, but also a third-party observability tool called LangFuse. So we are basically collecting traces of the agent interaction, and then on top of that, running offline evaluation during the development phase to make sure that this application is working as expected. So to showcase you how all of this works in action, what we've put at the top is a front-end application powered by Streamlit. So all of this is kind of, I'm going to demo and show you how all of this works together. But we've also open sourced this, and at the end of the presentation, we're gonna share the GitHub, resources with you so that you can also, try it hands-on or take it to your builders and get feedback on how all of these foundational components work together. So as I mentioned, right, this is basically a customer service chat application that is leveraging light LLM gateway built on AWS infrastructure. So this agent has access to your choice of models, and it has 2 modes. It has a local mode as well as a mode where the agent is hosted on Agent Core runtime. So you test it locally and then you deploy it on AWS, and you provide the ARN, so the identifier, the region, as well as it supports authentication. So you provide the user access token that authenticates the user. And as you can see, it's integrated with Light LLM Gateway. So this agent has a list of models that it can access. Not just Bedrock models, but also models outside of Bedrock. So OpenAI models, for example. And then you also have user identifier to tag your traces. So I'm basically going to send it a hello, right? So I'm sending it a quick hello. And the agent responds based on the system prompt that I've set. So it's a customer service agent for any company. It's a dummy company, and I have some data that I've indexed, right? So I ask about how to reset my router hub. So there's a device that any company supports. And then the agent goes and provides an answer. So it's basically leveraging the retrieve context tool to provide me with an answer. And you can see that it also kind of lists down the sources that it leveraged. So which documents did it use to answer the question? And also what's the relevance of the retrieval? It also tells me other things like what model was used, what tools were used, and what was the citation. So what document, page number, and all of that. And also adds a trace ID for observability. I go on to ask another question, right? So I tried to reset the router hub based on the answer, but it does not work. The agent goes ahead and provides me with another addition set of steps, but then goes and says, I can create a support ticket for you if this is not satisfactory. So I go ahead and say, yes, let's create one. The agent then uses that information to further query and ask me about further details about my email ID, my problem, description, all of that, right? My details, which I go ahead and provide. So the agent is intelligent enough to pick all of that information to use as parameters for my create support ticket tool call, right? So you're not explicitly mentioning what are those parameters? So I'm just kind of in natural language providing all of that information, and the agent is going to pick that up and understand that it needs to call the create support ticket tool that is hosted behind the agent core gateway. So in this case, you can see that a ticket was created using a third-party API. It provides me with all of the information, and then I can also see that the create support ticket tool was invoked in this process. Now I take a different route, right? So I ask the agent if it also happens to provide investment advice, and it tells me that your input contains content that violates our policy. So what we've also done is integrated with Bedrock guardrails to make sure that this application is safe and trustworthy. You can also have PII detection in place and other capabilities. I go ahead and then ask, what device did I ask help for? This is an example of short-term memory for session management. So I don't need to repeat information for the same session. It knows that I asked a question about the router hub, and I created a support ticket. Now what I'm doing is, I'm switching from local mode to the agent core mode. So I am very happy and satisfied with my agent, and I've hosted it on agent core runtime. I provide it with the identifier for my agent and a user access token, right? So as I said, it also has OAuth integrated. So I provide with that authentication token, and it now says that it's connected to agent core runtime. So now it's interacting with the agent on the cloud. So I again go and ask similar questions, right? So what kinds of devices are supported by any company broadband? It goes on and then again does the retrieve context tool call and behaves in a similar fashion. What I'm trying to show you here is that the local mode then can be hosted on the cloud. Here you can see is light LLM. Chaitra talked us through this gateway. I'm showing you this UI, which shows you a model catalog. That is basically the shared component. All of the different models and providers that are supported in your enterprise via the Light LLM gateway can be checked out here on the UI of Light LLM. You can create access key, as Chaitra was mentioning, an API key for your team or your use case, and then attribute cost to that team or to that use case, right? There's also a playground where you can basically use that key and test it out. And then you also have a very comprehensive usage dashboard, which tells you what is your spend per team, what are the top API keys, what are the top models, what are the top providers that are being consumed in your organization. Right? So moreover, there's also logs available. So as Chaitra was talking about logs and traces, these are logs for model invocation. So every invocation that my agent made, I now know what were the total tokens, what was the cost, was it a success, or was it a failure. So this is how Light LLM looks like. I now switch to the observability tool, which is Langfuse. In this example, what I'm going to do is I'm going to look at the traces generated for my agent invocation, right? via the Streamlit application. So I go to this tracing tab for my platform, and I just filter down for the latest trace, which was the trace of the interaction that you just observed, right? So in our code, we also tag these traces. So very easily, you can filter out and categorize all these traces when you're creating metrics on top. So in my case, it's a LangGraph customer service agent trace. And this is the user ID that you also saw in the front-end application. So you can attribute it to user IDs, project IDs, so on and so forth. And these are the different metadata that's being collected as output of your agent trace, right? You have a timeline view, so you can also check what time it took for every step. So if you see that your agent is really slow, you know, was it the retrieve context step or was it the create support ticket step that took a long time? And you can easily optimize the speed and the latency of your agent. So here, there are different steps, and it has different kinds of metadata, right? So the create support ticket step, for example, has all the parameters that were used to invoke this tool call. So for your retrieve context also, you can also get details like what was the relevance score, what were the items that were retrieved, and so on and so forth. What I'm now going to do is also show you how we are collecting user feedback, right? So as Chaitra also mentioned, this is another important metric that we collect, right? So I'm going to ask a couple of questions to my application. So the agent is going to answer these questions. And if I am satisfied, which I am, I'm going to put like a helpful thumbs up and also provide certain natural language comment, which can be, kind of worked upon to gain insights about the performance. And we are collecting this as well on LangFuse. So as you can see, we have something called user feedback, which we are normalizing and also collecting some, comments to understand how all of this works. I am now basically going to demonstrate how offline evaluation works. So this is a basic Python script that we've created where we are using some ground truth data to kind of send some queries to my agent. And then I'm collecting the traces from LangFuse to use LLM as a judge to create certain metrics like latency, faithfulness, correctness, also tool accuracy. So my expected tool call was, say, retrieve context, and the agent went and created a support ticket. So, the accuracy was 0. So these kind of things you can create during the development phase and incorporate in your DevOps pipeline. So as I said, we've open sourced this. So also looking forward for you to check this out. Chaitra is going to share the resources with you later. But just to kind of recap, right? So we have the LLM gateway that leverages Bedrock and other models. You have the tools gateway that leverages different tools. And then you also have different components like observability and offline evaluation, where you bring in your golden data set and then create different metrics, right? So I have a query. How do I reset my router hub? And I have expected tool calls like retrieve context. And we're using some Python logic to create tool accuracy, parameter accuracy, and also LLM as a judge to create response quality metrics like faithfulness and so on. Moreover, we also provide infrastructure as code, as I was mentioning. So it's available in Terraform. And the main purpose of this is that developers and builders can quickly deploy and test out this solution end-to-end to understand how all of these foundational components are being stitched together. So everything that you see and everything that was deployed as part of the demo can be deployed end-to-end with infrastructure as code. So yeah, this was basically the demo. We saw a lot of things there, right? So we saw the light LLM gateway. We saw Agent Core runtime hosting your agent. We also saw Agent Core gateway, which had different tools behind it. All of this was tracked and monitored with LangFuse. And then we had offline evaluation on top. This is all I had for the demo, but we have more in store for you, and it's a pleasure to move on to the next segment. I would really like to invite Dave Senior on stage, who will tell us more about how Sage is implementing agentic AI in their organization and leveraging foundational components. Welcome on stage.
Thank you, and thanks for the invitation to present here today. So we'll start off with a little bit about who Sage is and what we do. We mainly work in the areas of accountancy, HR, and payroll. We produce software in those domains. We've got some growth numbers there on the screen as well. There's 11,000 employees worldwide, well, slightly more than that, spread across 20 countries. We have 6 million businesses worldwide that use Sage products. And a kind of fun fact there is a quarter of the UK employees are paid via Sage software. So what have we got today in the agent space? We have our help search. I think everybody's building these types of solutions at the moment. So RAG-based help search. Our product teams can integrate this into a product within 5 days into production, which is a great performance. We have our instant analysis. So instant analysis uses LLMs to summarize financial reports and answer customer questions on them. We have our accounting agent. This actually wraps up a lot of functionality where we allow customers interact with the product through some natural language and also be delivered insights into changes in their data, potential errors in their data entry. And then we have our agent for close is another example where we have an agent that helps customers do a period close in the accounting product. But we have some challenges as well. So we have a very distributed architecture. Sage has over 200 products worldwide, and we've grown massively over the years through acquisitions. Because we have such a big organization, decision-making is distributed as well. And while my team is a central services team and we're building AI solutions, we're not the only team in Sage that are working with AI. Everybody is working with AI. In order to address our suite strategy, where we want to sell software in packages to customers, we also need to have an AI experience that straddles those products. So that means that a customer needs to be able to use our agents to interact with our HR products from our accounting products, and vice versa. We also want to be able to work with a payroll. So this is where our agent mesh approach comes in. So just a moment on agentic mesh architectures. We've got a few examples here on screen. We've got the basic mesh, which would be for a smaller setup, maybe with an agent registry, maybe not, which allows agents to interact with each other using the agent-to-agent protocol. We have the gateway mesh. So a gateway mesh would require all agentic requests to go to a central point to be routed to the appropriate agent. So the challenge with that is when you have a large organization trying to centralize everything like that, you build a single point of failure and you build a requirement on every team in your organization to integrate with that. We've also got an example here of a hierarchical mesh where we have, as it describes, a hierarchy of orchestrators and agents. And then a more complex mesh would be a federated mesh where you've got bridges between multiple meshes and maybe multiple authentication sources as well. But this, sorry. So this is what we've come up with for our architecture. This is our agentic strategy for Sage. And it's using a combination of the different meshes that we showed previously. So if we talk about this from the right to the left, we can talk about what we've got today and what we're working on for the future. So we have our tools on the extreme right-hand side. We have our MCP servers. We also have MCP-like solutions that we built pre-MCP before the industry had settled on that standard. Workflow orchestrators and solutions like that. And now we're starting to use the Agent Core Gateway for MCP as well. And we have these spread across multiple business units and multiple products in Sage today. So in front of our gateways then we have our agents. We have 3 types of agents that we've defined in our architecture. We have specialized agents that do particular role-based tasks. We have planning agents that can plan complicated tasks to be orchestrated across those role-based services, or agents, sorry. And then we have our main agent. Our main agent is our orchestrator. Our main agent would be the point of entry for the agentic experience within a product. When a customer opens up the agentic experience within the product, they'll be connected to the main agent. And based on the user's request, the agent may need to use the planning agent to request a complex workflow to be orchestrated across the specialist agents, or they may just trigger a specialist agent for a simple task. The other alternative is that the user has requested an action that is not supported in the local product. So in that example, maybe you're doing some data entry in your accounting software, and then you remember you've got a new start next week, so you ask your agent to create a new user in the HR platform. In this situation, the main agent will have to go to the agent mesh. It will look up the customer's entitlements based on the tenant that they're signed in context of. And then it will, and sorry, that's happening via MCP. So we have an MCP gateway for that, where we're looking up our entitlement service. We're getting the HR product that this customer's tenant has purchased from Sage. And then we would do an agent-to-agent handoff to a main agent for that product using the agent-to-agent protocol. The user can then interact with the main agent for HR in a similar manner, where maybe it's a complex task that a plan needs to be generated by the planning agent, or it's a simple task that's just triggering a role-based agent. Outside of our product domain within our mesh, we also have observability, because as was mentioned earlier, in order to have a good understanding of what is happening within your environment, you must have observability. We need to be able to trace not just the agent interactions, but the triggers that go through our products as well. So if a user is triggering an API within our product, we need to be able to see the successful completion of that action or the failure. We also have a centralized identity, which is part of our mesh here, using our Sage ID service. All users are authenticated via Sage ID. However, access control is not centralized. Access control exists within a product domain. So if you did request an action for the HR agent, you may or may not have permission to complete that action. That action would have to be, the agent would have to look up the entitlements within the local product and understand whether or not they can perform that action on your behalf. We intend to also build a just-in-time elevation of privilege, where you could actually, the agent could request to a more privileged user to perform the action on your behalf for that one time. So what's next? We're looking at modernizing the agents that we've built to use Bedrock Agent Core. Most of what we've built today within my team has been built on AWS services. So the phrase modernize is kind of funny to use considering how new AI and LLMs and this world is, but that's how fast the industry is moving. So we're looking at bringing our architecture up to date with Bedrock Agent Cores and consolidating into our mesh. Today there's a lot of isolated AI experiences within Sage. We want to bring this together for as a single mesh. And then our next step after that is to build more agents. So we will be publishing internally our own reference architecture for how we need to build agents. Thank you for your time. I'm going to hand you back over now for another piece on agent ops. Thanks.
Hello? Okay. Agent ops. Now, it's not a single solution that we can provide. It's not a single tool, right? Ops is a collection of processes and tools so that you are able to take these and manage it in production. Now, if you take the life cycle from prototype to production, every step ops is about giving that capability and components to move to the next step, right? So in the prototype phase, developers need access to different models. So a way to experiment quickly with all of these different models, way to experiment with different agent frameworks, and do some kind of A/B testing. Then when it goes to development, giving an environment where they can, like a sandbox environment where they can deploy this and start to integrate observability into it, start to run evaluation. Dev also can do evaluation. And then integrate into these other services that we talked about, like gateways, right? And then when it comes to testing, it's more about end-to-end QA testing, but you can also run evaluations there because maybe you have a different set of data in QA system. Then once it goes to production, live monitoring, which we already talked about, but it's also about security and governance, right? Keeping auditability, auditing the system regularly, and then having all of this bias and toxicity and risk assessment done regularly. Now, it's also about the DevOps process, right? Managing the life cycle of these applications and agents. Agents have to be decommissioned, models undergo version changes. So how do you put all of this together? That forms the big term, what we call operations. Now, giving an example of what does maybe a pipeline look like? Let's say an agent developer has developed an agent. You can have Git flows to check out that code, build a container. I'm talking about a container here because I'm giving an example of agent core. Deploy it to agent core, and then run some evaluation. And this evaluation could be that it is run in the dev account, let's say as a container, but not necessarily. As Amna was showing, you can run a script locally, test that dev endpoint against a golden data set, make sure it's performing as expected. All good, you put it in a registry. Agent registry is something, there are some tools out there, or you can start to store this metadata. Here I'm showing some kind of a database that you can start to store. And from there, you're deploying it to QA, run more evaluation. Maybe this data set is different than the dev data set. And all of the time, you are sending traces to here as an example, LangFuse. Now, LangFuse has a feature called environments where you can have dev, QA, prod, so that you're isolating these traces, and that's a very good way to architect these different accounts. And if it is not as expected, you start to optimize. All the cycle begins again, make more changes, maybe use different models, maybe use different prompts. And then once everything is okay, here it's a manual approval always before going to production, and you deploy to prod. Here, you're doing online evaluation. Now, this online evaluation could be something you build, or these tools also have capabilities to do online evaluation. For example, if you use LangFuse, you can use their online evaluation capability to do that. Just make sure you're sampling certain required data to be able to do that. And then you're collecting user feedback from the app. Everything goes into the observability system. And this is an example of how an agent DevOps can be set up. Not necessarily saying everything has to be this way, but just an example for you to look at. What does operating at enterprise scale means? Let's say you're a platform team or an IT team, and you are setting up this foundation. And how do you set it up? If you go back to the cloud operating models that we all have seen, centralized gives a lot of good standardization. Decentralized gives sort of agility to those end teams, but federated, where it's kind of a balanced approach. So maybe where I say the platform core, that is our foundation. Maybe that gives some shared services. For example, model catalog and gateway is a great example. That could be a centrally centrally hosted thing. Now, that doesn't mean it's one deployment. It could be several deployments, but you are controlling it. You're governing it in a central fashion. Agent foundations, by what I mean by that is runtimes, memory, tools can also be part of the platform. If you are customizing models, means fine-tuning, pre-training, that infrastructure can be part of the central platform. And then observability. Now, on the left-hand side is what these consuming applications are. Either they own their data. A lot of time, platform team does not want to bother about the data, so maybe it's the consuming team's responsibility. Again, this can be sliced and diced in a different way. I think the key thing to understand is adjust to your operating model the way you have been organized. Just to recap, this was the foundation we talked about, and it is extensive. What you need to keep in mind is set up the core capabilities. You don't need everything. What do you need to build those applications is more important. But there are certain things that you absolutely have to build, which is observability and safety. Have a platform mindset. I think it is more and more important because governance is a big piece of especially agentic AI. How do you centralize this governance? How do you manage the risk centrally? So having that kind of platform mindset is good. Not that much that it stifles innovation. So design for flexibility. You know, a lot of times when you centralize, it stops the agility factor of it, right? You become a bottleneck for all of these different teams to build and deploy these applications. So there is a fine balance like we talked in federated. Here are some resources for you. All that we talked about, not all of it. Some of it is in the first blog, which is the first one. The second one is a blog that we published talking about the LLM gateway solution that we showed. The first one at the bottom is the guidance that Amna was talking about, the solution they have published. It's open source, so take a look. It will give you that leg up to start to build your foundation. And then the second one at the bottom is the MCP registry and agent registry solution that we talked about. If you want to continue building your agentic AI skills, here is a skill builder link. Please feel free to explore that. Do not forget to take the survey. It's important for us to get feedback, good and bad. So thank you for your time. Appreciate all of you being here. Thank you.